Hello everyone, today's lesson is 7.5, solving polynomials in factored form. It's going to be a quick lesson, so let's get started. Okay, solving polynomials in factored form. 7.5, we just finished up the quiz, 7.1 through 7.4, great job on that. So we're moving right into 7.5, solving polynomials in factored form, okay? So we're gonna start with this. Before we actually learn how to factor, we're gonna actually do some solving with them and go through the zero product property here again. And let's start with this lesson 7.5. Okay, so in this lesson today, you will solve the polynomial equations that are in factored form. Okay, so that's going to be our statement. Our essential question today is, how can you solve a polynomial equation that is written in factored form? Okay, let's just talk about the two now. A polynomial is in factored form when it is written as a product of factors. Okay, so when we call a polynomial factored, it is considered a product of factors. Okay, so here's some examples of standard form, and the same exact polynomial over here is in factored form. So basically, x squared plus 2x is considered in standard form. And factored form of this polynomial would be x times x plus 2. The standard form of the second polynomial, x squared plus 5x minus 24, is x minus 3 times x plus 8. Okay, so we haven't covered factoring yet, but we are going to be covering the solving of it. Okay, solving the equation first, then before we learn how to factor. Okay, so when one side of an equation is a polynomial in factored form and the other side is 0, we can use the zero product property to solve the polynomial equation. The solutions of a polynomial equation are called roots. Okay, so that's what we're going to do today. We're solving the polynomials using polynomials that are in factored form and the zero product property. Okay, let's go through that again. We've had it before. But basically what the zero product property states, that if the product of two real numbers is 0, then at least one of the numbers is 0. So for instance, if you have an A and a B and they're real numbers and they're multiplied together, A times B, and it's equal to 0, that's going to tell you that either A is 0 or B is 0. Okay, this kind of makes sense. So if you think of two numbers that are multiplied by together that equals 0, if those out of those two numbers, so again, these are two numbers that are multiplied by together that are equal to 0, one of them has to be 0. A is equal to 0 or B is equal to 0. So this is zero product property. We've had it before and we've covered this before. So this should be a review in some cases, and the examples today are going to cover this solving at a pretty good pace here. Okay, so let's go through the first example. 1, solve a polynomial equation. So this polynomial is already in factored form. So x times x plus 8 equals 0 is in factored form already. Okay, so you look at this first one here, and if you're going to solve it, we're going to say to ourselves, in essence, you're saying to yourself, what number x times x plus 8 equals 0? Okay, so a number times a number equals 0. So that tells you that x is equal to 0 or x plus 8 is equal to 0. Okay, so we're using the zero product property to determine this. Okay, so either x is equal to 0 or x plus 8 is equal to 0. I just put 8 down. Let me get that out of there. So the x plus 8 is equal to 0. All right, so we end up with our two answers. X is 0, or x by subtracting 8 from both sides. X is -8. So these are what are called roots. So the two roots here are 0 and -8, or -8, I should say, or 0 and -8. So your answer in this case would be x equals 0 and x equals -8. Our roots, R-O-O-T-S. Okay, letter B, solving polynomial equations. So in this case, you have an x plus 6 times an x minus 5, and it's equal to 0. X plus 6 times x minus 5 is equal to 0. All right, so to solve for x here, you're going to basically say to yourself that x plus 6 could be equal to 0, or x minus 5 could be equal to 0. X plus 6 is 0, or x minus 5 is equal to 0. Okay, so if you're solving this now by subtracting 6, so you have your two roots that you're determining. You have basically two equations. Subtract 6 from both sides. You have x is equal to -6. And in this case, you're going to add 5 to solve for x on both sides of the equation. And you're going to end up with x is equal to +5. So the roots are -6 and 5. Okay, so that's example 1. Your basic equation solving polynomial equations. Let's do a couple on your own here. Solve the equation. So basically we're trying to determine what the value of the variable is that makes the equation true. All right, this first one's quite easy. If you have an x, and if you multiply it times an x minus 1, and if that's equal to 0, that means that x is equal to 0, or x minus 1 is equal to 0. Because you got to think about it. You're taking two numbers and you're multiplying by them together, and one of them has to be equal to 0. Okay, so if you add 1 to this side, you already got the 1 root as 0. Add 1. You have x is equal to 1. So your answer for number 1 would be x equal 1, x equals 0. Number 2, 3t times t plus 2 equals 0. 3t times t plus 2 equals 0. Okay, so that tells you that 3t equals 0, or t plus 2 equals 0. Okay, so you've got either this is equal to 0, 3t, or t plus 2 equals 0. Okay, let's solve for t. 3 times t equals 0. T is equal to 0 on this one. Or subtracting 2 from both sides, you would have t is equal to -2. So we're solving polynomials using the zero product property. All right, 3 and 4. Z minus 4 times z minus 6 equals 0. Okay, what that's going to tell you is that z minus 4 is equal to z minus 4 is equal to 0, or z minus 6 is equal to 0. Solving for z, add 4 to both sides on this equation. You'd have yourself z equals +4. Okay, that'd be one root. And the other root would be z adding 6 to both sides. Z is equal to +6. So your two roots to solving number 3, z equals +4 or z equals 6. And the last one, b plus 7 quantity squared. B plus 7 quantity squared. Basically, you have one factor, b plus 7, and that has to be equal to 0. Okay? So, and if that's the case, you could always expand this out and show it b plus 7 times b plus 7, but it's the same. So by subtracting 7 on both sides of the equation, you have b equals -7. B equals -7. So just one root there for b plus 7 quantity squared equals 0. So this is the zero product property, and this is solving polynomials using that property. Now, these are already in factored form. These are all polynomials that are in factored form, which we're going to learn how to factor shortly. Okay? All right, number 2, solve a polynomial equation. All right, so what are the solutions of 2a plus 7 quantity times 2a minus 7? And that's equal to 0. So if we're going to solve this, you've got your one factor here, 2a plus 7. And that's equal to 0. Or, so if you think, you got to think again. Now it's two factors multiplied by each other, and it's equal to 0. So one of them has to be 0. 2a plus 7 or 2a minus 7 equals 0. Okay, this is a two-step equation that we're solving. Okay, so if I subtract 7 both sides, I have 2a equals a -7. Divide by 2a, 2 I should say, you get -7/2. A equals -7/2. So I can already take out a, and I can already take out b, c I should say. And it appears my answer is going to be b, because -7/2 is not even offered here on D. So let's take a look at this just to verify that we can get the other 7/2. So add 7. You get 2a is equal to +7. Divide by 2 on both sides. A is equal to 7/2. So your answer is B, -7/2 and 7/2. Okay, example 3, real life application. Okay, so what we have here is a question about a fireplace. Okay, and let me move my dialog box up. Okay, there it is. So what this is, it's a fireplace. So if you look at a fireplace, here's the flame, okay, going up and down like this. So there's the flame. And what it is the arch of a fireplace can be modeled by y is equal to -1/9 times x plus 18 times x minus 18, where x and y are measured in inches. The x-axis represents the floor. So down here's the floor. Right here is the floor. Find the width of the arch at floor level. Okay, so what we're trying to do is we're trying to find the width of this arch. Okay, so this arch would represent the encasing of the fireplace. The floor is here. So we're trying to find this width from this point here, and then we're find this point here. So basically, the y of these ordered pairs is 0. Okay, so these coordinates, I should say, the y is 0. So if you had to actually identify these, this would have a negative number, and this would be a positive number. But we're asked to find the width of the arch at floor level. Okay, so we're trying to find this dimension. Okay, so we're trying to find the x this side, and that same x should be on this side. Okay, the positive side of it. So our y is 0, and if it's 0, our equation that this arch is modeled by, because the equation that we're given is this arch. Okay, see how it comes down like that? And where it crosses the x-axis on each side, that distance altogether would be the width of the arch. So when y is 0, we should be able to find out what x is. You can already probably see it for most of you. When y is 0, it's equal to -1/9 times x plus 18 times x minus 18. So that tells you that x plus 18 is 0. Or x minus 18 is 0. If you're subtracting 18 from both sides, you'd have x is equal to -18. And if you added 18 from both sides, you'd have x is equal to +18. So from the middle of the fireplace here, you're going to have a -18 on this side. Okay, it's a -18. And you're going to have a +18 on this side. Okay, now it's a fireplace. It's got a nice flame to it. What is the width of that arch? So what would be the actual physical width going across? Well, we're talking about positive distance here. So you have 18 units, another 18 units. So 18 and 18 is 36. So your answer between the two units is 36 inches. 36 inches. Okay, to finish up here today, we have 3 on your owns. All right, so let's just go through those to finish up this quick lesson today on solving polynomials in factored form. Number 5, solve the equations 3p plus 5 times 3p minus 5 equals 0. All right, again, so it's a number, 3p plus 5, times a number, 3p minus 5, and that's equal to 0. So to find your roots of this, you're going to take your 3p plus 5, and you're going to set it equal to 0. You're also going to take 3p minus 5, and you're going to set it equal to 0. Okay, so you have your 2 equations to find your roots. So if you subtract 5 on this side, on this first equation, you'd end up with 3p equals a -5 divide by 3, -5/3 would be 1 root. And you can see if you add 5 to both sides, you end up with the +5/3. Divided by 3, divide by 3, and you have a +5/3 for number 5. Okay. Now don't get lazy and always put the positive and negative. You want to figure them both out, because sometimes they don't exactly turn out that way. In this case, they do. And but don't get lazy and just say, well, I've got my -5/3, so it's +5/3. It doesn't always turn out that way. Okay. So let's do number 6. 12 minus 6x, quantity squared, equals 0. Okay, so you gotta think. Oh, you have a number that's squared equal to 0. That means that that number inside the parentheses, 12 minus 6x, has to be equal to 0. Okay. All right, and if you're gonna solve for x, get x by itself, I can add 6x to both sides. I have 12 is equal to 6x. Then if I divide by 6 on both sides of the equation, I have 12 over x, 12 over 6, I should say, is 2. So x in that case is 2, okay? And you might want to get in the habit, there's not a lot in the book here that talks about making sure we have the correct answer. You can always take your 2, put it back into your equation and test it. Give it a testing, see if it works out. In the last one today, we're going to talk about, it's similar to the fireplace question, but this is a mine shaft, okay? So a mine shaft can be modeled by y equals -1/2 times x plus 4 times x minus 4, where x and y are measured in feet. The x-axis represents the ground. Find the width of the entrance at ground level. Okay, so if you have a side of a mountain, there might be a shaft like this, okay? And so they're looking for, when y is equal to 0, what the x would be here. Some of you might already see the answer. So y is equal to 0, -1/2. And again, this is just a representative of this. I'm not sure if it's accurate or not, but it's close. X plus 4 times x minus 4. Very similar to the fireplace question. When when y is 0, you're determining out this value right here, what this value is, and this value here. So here and here, okay? All right, so you can see that x plus 4 is equal to 0, and x minus 4 equals 0. That would tell you that x is equal to -4, and also tell you that x is equal to +4. So this value here is -4, and this value here is +4 of the mine shaft. But they want to know the total distance of the width of the entrance. Okay, so this total distance is not going to be -4 or +4, it's going to be 8. So 8 is the distance of the width of the mine shaft for number 7. Okay, so that concludes the lesson today. The lesson is on solving polynomials that are already in factored form, and we use the zero product property. And keep in mind, we haven't really got into factoring yet, but we are going to be doing that shortly here. But these problems here are already in factored form, okay? So we can solve it by using the zero product property and set our 2 roots equal to 0 and do our solving. So hopefully this was beneficial. Take a look at the assignment I have posted. It's a short one. And we'll talk with you again soon. Take care. Bye-bye.